Welcome to this UASMaster video tutorial showing how to set up the training data UAS3D in TBC and to export it to UASMaster. For this video we are using TBC version 4.00 and start a new project. We will use the blank template and change the coordinate system to UTM 32 North. We will select therefore the Change Coordinate System function. You can find this in the Home tab here in the geodetic part. Either you already have used recently the 32 North WGS84 system, or you select it from Coordinate System and Zone. You go to Worldwide UTM and select 32 North here from the zone. We leave the datum to none and we will not apply a geoid model. Then we press Finish. Next we will import the ground control points and we will use in the Home tab the import function. Please navigate to the folder where you installed the demo data and go to the subfolder Input. Select the folder Input and say OK. To import the ground control points, select the file yberg_gcp text and choose from the bottom here Import. The import format editor opens up. We are going to select the entry point ID east north elevation and coding as control. We see that at the moment the import will fail because it uses here comma and not semicolon. But we can change this during the import. So we select the format, we say next, we use delimited, and now we choose as delimiter semicolon. And then we see here how the import will now not fail but be successful. We continue the import wizard and we just leave here the settings and say import. And we will not change the definition, so the format PEN coding will not be changed to semicolon but stays with comma for future other imports. The ground control points have been added. You can see them here on the left side in the Project Explorer. When we extend here the point list, we see here all 14 ground control points. We can also extend the first, for example, and double click it, and then we see here the coordinate of the point and the name of the ground control point. Now we want to export the TBC project to UASMaster. Therefore we select the Photogrammetry tab and choose Send to UASMaster. On the right side we can now choose the UASMaster version which exists on your computer. As this project is a close range project, we will use UASMaster 9.0 here as version, and we will additionally also choose all our control points. Therefore we select all the entries, which are 14 of these ground control points. Then we can press OK and UASMaster opens automatically, offering us here a selection. Here we can now select a close range 3D project type, which allows us now to use these images to extract a dense point cloud for objects and buildings, also from a vertical perspective. Please choose a destination folder to save your Inpho project now here. After choosing your destination folder and defining a project name, we press OK. And now we can continue to edit our project. We have now already included our ground control points and also our coordinate system from TBC. In case we want to change the standard deviations, we can enter here again our default standard deviations for our accuracy in the imagery and also in our object point accuracy, where we will place them to 2 cm in position and 4 cm in height. We need then additionally to add our imagery, so we will go to the frame type and import here the files, selecting here a directory. Please navigate here to the images folder that is installed from the demo data and select the folder. We will go through the wizard and import our photos and create the camera from the EXIF files from the photos. Our photos include GNSS information where the height is above sea level, so we leave here the entry sea level, and when we will look at our ground control points, we see that the mean terrain height is something around 375 meters. Entering the values, we continue the import, and we will see now that the images are imported with the camera information, and therefore we have now our XYZ coordinates to WGS 8432 north, the height above sea level, and the camera information from the EXIF file here in our frames. The camera was automatically extracted from the EXIF file and was here automatically placed here into the camera dialog, where we see the sensor size, where we can see the focal length, the pixel size, and also distortions if they would exist in the EXIF file. Looking at the GNSS data, we see that the standard deviations are set to 10 meter and about 1 millidegree, which is fine for this project. We can say OK to the GNSS window and save the project, and we have now all the data included that we need to continue with our next video, which would be the 3D reconstruction. So we can close the project editor and zoom out with the wheel, use the right mouse button and keep it pressed to see here the setup, and then we can now go with the next video, which is the 3D reconstruction, which is exactly the same as if you would have set up the project completely in UASMaster. The same steps will also be done as in measure and in calibration, and also finally the surface generation. After extracting the dense point cloud with surface generation, we will show then in a final video how to export now again from UASMaster to TBC, or to bring the data back to TBC. But this will be in a different video, so thank you for watching this video tutorial.